So today we are going to solve quadratic equations using the quadratic formula. Yesterday we solved quadratic equations by factoring, and today we're going to have this nifty little handy little equation that we can use to solve for any of them at any time if we want to. We just have to memorize the formula. And here is this nifty little formula. Okay, take a second to write this down. It's going to be very important. In words, the solutions of a quadratic equation of the form ax squared plus bx plus c equals 0, where a cannot be 0, are given by the following formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I know that some people may have learned this by song or something. I'm definitely not going to sing for you, but I might find a little video and have you guys listen to that, because sometimes it's easy to remember things by song. And then it gives you an example. So make sure you have this written down. I think that the greatest thing about this is that you can use this at any time as long as you remember the formula, as long as you're working with quadratic equations. If you want to find the zeros or the solutions to that equation, you can literally use this every day, all day, anytime you want to. You don't have to factor. Sometimes factoring can be easier because you don't have to go through all these steps, but if you're good at basic manipulation of numbers and variables and know where things go, then this is a beautiful way to not ever have to factor again, which is not my favorite, so that's why I love the quadratic formula. So let's go ahead and take a look at an example. We have x squared minus 10x equals 11. So in order to use the quadratic formula, we need the equation to be in standard form, correct? So we need it to be equal to 0. And we don't have it equal to 0, we have it equal to 11. So we need to get this 11 gone from this side, so we subtract it from both sides. And we're left with x squared minus 10x minus 11 equals 0. So this is the equation that we're going to work with right here. Okay, so we need to identify our a, b, and c, so our coefficients, so that we can go ahead and plug them into our quadratic formula. So our a is the coefficient in front of our x squared term. So you remember there's always that invisible 1 there. So we have a equals 1. B is the coefficient in front of our x term, so b equals negative 10. And our c equals negative 11. Okay, so that's super important. Let's go ahead and write down the quadratic equation, quadratic formula. Okay, so I have the quadratic formula written out, and what's beautiful about this is we know what a, b, and c is, so all we have to do is just plug and chug. Okay, so we take x equals, our b is negative 10, so if it's the opposite of our b, the opposite of negative 10 is a positive 10, so we have 10 plus or minus square root of negative 10 squared minus 4. A is 1. C is negative 11. Extend that bad boy. All over 2 times 1. Okay? Alright, let's take a look at this. So we have x equals 10 plus or minus. Let's focus under this radical right here. Okay, negative 10 squared. So negative 10 times negative 10 is a positive 100. Then we have negative 4 times 1 is negative 4. Negative 4 times negative 11 is a positive 44. So we're going to add 44 all over. 2 times 1 is 2. All right, so now we can continue on. 10 plus or minus square root of 100 plus 44 is 144, all over 2. Still not quite done yet, so we bring it up here. X equals 10 plus or minus. Okay, so we're looking at what the square root of 144 is. So what times itself gives us 144? And the answer to that is 12. Okay, all over 2. Okay, so by this point you're probably asking yourself, well, what the heck is up with this plus or minus deal? I don't understand what that means. So if you remember from our previous video, we have two solutions, right? Because we could potentially have two solutions because the parabola is going through the x-axis in two spots. So that's where the plus or minus comes in. Okay, so we're going to take two different solutions. So we're going to take one with the plus and one with the minus and put the or in the middle there. So let's go ahead and do this, because in words it probably doesn't make a whole lot of sense. So if we have x equals 10, we're going to take the plus one for this, plus 12 over 2, or, there's where the or comes in, x equals 10 minus 12 over 2. Okay, and now we're going to go ahead and simplify both of these. So we have x equals 10 plus 12 is 22 over 2, and 22 over 2 is 11. Okay, so one of our options is 11. And then we get x equals 10 minus 12 is negative 2 over 2, so x equals negative 1. So here are our solutions. We have x equals 11 or x equals negative 1. So if we write them in our set notation, we have x such that x equals 11 comma negative 1. And those are our solutions. So if you noticed, all we had to do instead of factoring this, we can just memorize a formula, which is this quadratic formula, and plug our values in and find our answer. So everyone has different preferences, but here is another way to do that. It is also important that you take your solutions and plug them back in to make sure that they're correct. So if you plug in x for both of these to make sure that you do get 11, and negative 1 into both of these to make sure that you do get 11, that is extremely important and will definitely benefit you. And we're going to be doing that in class with our calculators. So we're going to double check ourselves with our calculators also. So I want to go through another example with you that you may run into problems like this, and it's going to lead into what we're going to be talking about next. So this is going to be a little preview about that, but it's important that we go through this example as well. So here is our quadratic equation that we're looking at, and we're going to again determine what our a, b, and c are. So our a in this is 1, our b is negative 6, and our c is 10. Okay, now we're going to plug them into our quadratic formula. Okay, so here's our quadratic formula. And let's go ahead and start plugging things in. So we got x equals negative b. So it's the opposite of what b is. So we have a negative 6, so it's a positive 6. So we get 6 plus or minus square root of negative 6 squared minus 4. A is 1. C is 10. Okay, all over 2 times a. A is 1. Okay, let's continue our simplification. 6 plus or minus square root. Negative 6 squared is a positive 36. Then we have negative 4 times 1 is negative 4 times 10 is negative 40, so we do minus 40. All over 2 times 1 is 2. Keep simplifying. We get 6 plus or minus. 36 minus 40 is a negative 4, all over 2. Okay, so I want you to take a second and on a calculator, look at your phone, look at something, and try to do the square root of negative 4 and see what it tells you. So it should have come up with an error of some sort, okay? So the reason is that in the real number system, you cannot take the square root of a negative number, okay? You cannot have the square root of a negative number. However, this is when we introduce imaginary numbers, okay? So we're going to get into the imaginary number system, okay? So we've got real and imaginary. So you might have learned about the number I. The number I, that's imaginary number system, okay? So for now, I'm going to pause this right here because I'm going to introduce you to complex numbers and the imaginary number system, okay? And this reason right here, why they are trying to take a square root of a negative number, is why they came up with this imaginary number system. It's a way to solve the problem of taking the square root of a negative number. So as we jump into imaginary numbers, these are some of the vocabulary words that you're going to need to know. So you've got imaginary unit, pure imaginary unit, and complex number. Okay, so let's start with a little bit of background. So you have pure imaginary numbers. In your math studies so far, you've worked with real numbers. Equations like the one previously led mathematicians to define imaginary numbers. So the imaginary unit I is defined to be I squared equals negative 1. Okay, so the number I is the principal square root of negative 1. So that means that the square root of negative 1 equals I. Alright, so when we have numbers in the form of 6I, negative 2I, and I times the square root of 3 are called pure imaginary numbers. Pure imaginary numbers are the square roots of negative real numbers. For any positive real number b, the square root of negative b squared equals the square root of b squared times the square root of negative 1, or b times I. So I know that sounds a little bit convoluted at this moment, but the main thing I want you to get from this is that that I equals the square root of negative 1. Okay? That's what I want you to get. And that I squared equals negative 1. That's what I want you to understand from this so far. So in problems like the one that we were working on earlier in this video, we are going to be needing to use complex numbers. Okay, so a complex number, take a second and write this key concept down. So in words, a complex number is any number that can be written in the form a plus bi, where a and b are real numbers, and I is the imaginary unit. A is called the real part, and b is called the imaginary part. Okay, so if we're looking at this example right here, we've got 5 plus 2i. Then 5 is the real part. So 5 is just a number. We know that. We've worked with that a whole lot. Yes? 5 is the real part. You can even write this. 5 is real. And the 2i is the imaginary part. Okay? So if we're looking over here at the other example that they gave us, we've got 1 minus 3i. So it's like saying 1 plus a negative 3 times I. That's just another way to write it. So you can write it either way. Okay, because the complex number form is in a plus bi, so that's why they wanted to write it with a plus there. So let's take this right here and apply it to the problem that we got stuck on before. Okay, so we were here at the bottom with x equals 6 plus or minus the square root of negative 4 over 2. Okay, so I want to take this negative 4 and write it in some terms that we know, because we know that the imaginary I equals the square root of negative 1. So let's figure out how to write this as the square root of negative 1 times something. Okay? So we can break apart this radical and write it as x equals 6 plus or minus. And we can write the square root of 4 times negative 1. Okay, so we've got that negative 1 component in there, which is what we're looking for, so we can pull that out. All right, so we have, let's continue here. So we get x equals 6 plus or minus. All right, so when we have two things under a radical that are being multiplied together, we can split them apart into two different radicals. It's just the rules of the radicals. So we've got square root of 4 times square root of negative 1 all over 2. All right, so now we have x equals 6 plus or minus. We get the square root of 4. What times itself gives us 4? The answer would be a 2. And then we just learned that I is the imaginary number, and it is the square root of negative 1. So we have 2 times I, right? All over 2. Okay, so now we can break this apart. Or, well, we could simplify a little bit more first. Let's do that first. And just like when we solve equations and we have to divide, when we're dividing everything in our numerator by our denominator. So the 6 is being divided by 2 and the 2i is being divided by 2. So we can take 6 divided by 2 and you get 3 plus or minus. 2 divided by 2 is 1, so you're just left with an I. All right, so you can just leave it like this, or if you wanted to write it like this, x equals 3 plus I, or x equals 3 minus I. Those are all of our options. So these right here are our complex numbers. Okay, so these would be our solutions. So what this looks like graphically, let's go ahead and show you that, give you a full spectrum picture. Okay, so when we're looking at a graph and we have no real solutions. So you remember when we had our 3 graphs and we had the little picture and it said there was one that was touching the graph once, it was touching the x-axis once, one that was crossed it twice, and then one that said that it had no real solutions and the parabola never crossed the x-axis. So these complex number solutions are the ones that the parabola never crosses the x-axis. So our graph could look something like this, okay, where you notice the parabola never crosses this x-axis, okay, never. So that's what we're talking about when we're talking about it has no real solutions, but it does have complex number solutions. So if we go back and recap a little bit, if we're using our quadratic formula to find the solutions of a quadratic equation, we're able to find any and all of our roots, whether they're real or imaginary, which is kind of fantastic. So if you just memorize this right here, super important that you memorize this, or find a little song or something to help you remember this, because it is very helpful if you forget how to factor or if you aren't doing something correctly. This is super helpful. So we're going to practice with this formula tomorrow, and we're going to practice with finding complex number solutions, so our imaginary solutions. I know that it was probably like, whoa, there's such a thing as imaginary numbers. We're definitely going to get more into that, but I wanted to just introduce them to you and give you a context of why they're important and why we even have imaginary numbers, so that we're not just like, hey, here's an imaginary number, love it, but here's a reason why we're going to use it.